This is a code walkthrough for the example file SelectionNested2.java. So what this file is doing is it's prompting a user to enter both a wind speed and a temperature. We have two threshold boundary values for each of those quantities. So we have two regions for each of the two inputs, giving us a total of 4 possible combinations of weather conditions. And for those 4 possible combinations, we're going to determine a suggested activity based on the conditions. And we're going to do this in 2 different ways. Here we're going to use sequential if-else logic on 4 individual cases using compound conditions to determine what we should do. Down here we're going to do the same thing, except we're going to implement it as a nested if-else structure, where we're first going to check where we stand for the wind parameter. Then once we've determined that, we'll make a determination on the temperature parameter separately. So we're going to determine a suggested activity in 2 different possible ways, and we should get the same result either way. This example was presented in the associated lecture materials, so I'd encourage you to take a look back at that for the matrix of possibilities. So as always, let's start by compiling this code, and we will set a breakpoint on main, and let's single step our way through this once or twice, and then we'll free run this a few times. So let's start running, and we'll set up our wind and temperature thresholds, set up some starting output activity strings, and then we'll prompt for a wind speed. And let's assume it's a calm day, 10 mile per hour wind. And let's say it's a cool day, maybe 55 degrees. So according to our table, we should probably go hiking. So we've got a wind of 10 and a temperature of 55. So this condition will be true. This condition will be true. The AND of those 2 trues will be also true. So we're going to find the result in this first case. So we're going to string concatenate hiking to the end of this suggested activity 1 and print it out. And then down here, we're going to check if we're beneath the wind threshold. We are. So then we're going to go down to the next level and check the temperature. We're also below the temperature threshold of 80 degrees. So we'll find the same activity hiking. We'll append that to the output string and print it. And notice that we come up with the same suggested activity both ways. Let's finish this execution off, and let's run this one more time with some different inputs. Let's pick something to where we're going to have to go through and check multiple cases. So again, we're setting up our thresholds. Let's put in a high wind day, 30 miles an hour wind, and let's say that it is a hot day, so it's a hot windy day. According to our table, we should be going to the movies. So we're going to check this condition first. We have a false and a false, so we continue looking. Now we should have a false and a true, but overall that's a false, so we keep looking. We have a true and a false, so overall that's a false, so we fall through to this default case for the movies and print it out. Then in the nested if-else, we're on the low side of this threshold, so we're going to go to the else case, and then inside the else case we're going to check the temperature. We're on the low side of the temperature threshold, so we'll jump to this else case. We also come up with a suggestion to go to the movies, and we print that out. So everything's working fine. So again, just to recap, and let me finish off this execution, we're implementing the same logic in 2 different ways, using a sequential if-else here, using a nested if-else here. And there are some trade-offs. This logic is perhaps a little bit simpler. It's just simple if-else logic, but notice that the conditions are a little more complicated. This is a compound conditional expression. By contrast, this structure is perhaps a little more complex because it's nested. However, the individual conditions are each simpler. They're only checking one thing at a time. In either case, we've got 4 logical conditions to check. 1, 2, 3, 4. 1, 2, 3, 4. So it really boils down to our personal preference of which style to use to tackle this problem. So let's clear the output, and Let's free run this code a couple times and we'll try a couple of edge cases. How about something right on the boundary of 2080? This should give us 20 and 80. This should give us hiking for both cases. Let's try this again for a very windy day and a cool day, 55 degrees. This should give us kite flying. Very good. Let's try this again for a calm day and a very hot day. This should tell us to go to the beach. It does. And let's try one more case. A calm wind and a crisp temperature. This should tell us to go hiking. And it does. So the point here is to try enough test cases to where we're satisfied that all the cases are computing correctly. And we should also remember that we should try some edge cases that fall right on the boundary, and the outcome should fall cleanly on one side of the decision making or the other. Okay, that's it for this example.